My name is K Itabashi. I'm a graduate student, Department of Civil Engineering, the University of Tokyo. Today I'd like to talk to you about this topic. So I'd like to start with introduction. In recent years, we have several global issues such as urban environmental issues, public health issues such as pandemic, emerging infection diseases. To deal with these issues, we need to conduct impact analysis of climate changes on human and social activities. One of the most important data set for this analysis is the size, scale, and form of cities of the world. For that reason, global urban extent map has been global urban extent map with high accuracy and fine resolution has been constructed by mainly using optical sensors such as ASTA-VNIF. This image illustrates the example country regions in Japan. And this map shows the consistency of urban map from ASTA-VNIF with modest land cover map. The quality is poor in some regions. For example, in Southeast Asia, there are many red color pixels. Next, let me explain the major issues in constructing urban extent maps from optical sensors. First, the cloud contamination is a serious obstacle, especially in tropical climate zone such as Southeast Asia. Also in desert climate zone, barland and desert cause misclassification. It's because the barland and desert have similar characteristics in surface reflectance to urban area. To deal with these problems, it may be useful to use pulsar images. SAR sensor can observation in all weather conditions. Also, considering differences in characteristics between microwave scattering for SAR and surface reflectance for optical sensors. Urban area may be successfully detected in regions where ASTA could not detect. With that reason, loss pulsar images have a potential to detect urban areas successfully. So this study aims at developing a method of applying pulsar images to the generation of high accuracy urban extent maps and improving accuracy in the regions where ASTA could not detect urban area. The key point to achieve this goal is the development and automated and robust classification over the world with pulsar images and ASTA images. And, the feature of this study is the 2 points. I'd like to explain the first point, the number of test sites. Some researchers are detecting urban area with SAR data uses around 10 cities for accuracy validation. Meanwhile, this study uses around 10 cities of the world as test site for validation covering the globe. Next, I'd like to explain the second point, developing an automated and robust method for mapping. This shows the overview of classification method. The proposed method of this study consists of 3 main steps. First, I'd like to explain the first step, reducing non-urban areas. As a pre-processing step, we used existing coarse resolution global urban maps to focus on the urban areas. For mapping urban areas with further data, mountain and vegetational cover may be misclassified as urban areas because of similar reflectors. To reduce misclassification and focus on urban areas, in this study we used existing coarse resolution global urban extent maps. In this study we used Grump urban extent grid from nighttime light data and MCD12Q1 urban and built up data from MODIS. We used these 2 maps as mask data. We overlaid the images on pulsar images, and in this example, the red region is selected areas, and user processing will be conducting in this red selected areas. Next, I'd like to explain the second and third step, image classification, urban detecting, and accuracy assessment. After masking the pulsar images to eliminate non-urban areas, we conduce classification to detect urban areas. First, for an automated clustering, ISO data has been employed for round cover classification. Right? This left image. And second, for labeling step, we calculated percentage of pixel overlaps with MCD12Q1 urban and built-up class. Then the cluster which has the highest overlap was assigned as urban area in this study. After detecting urban areas, we executed accuracy assessment. For this step, we calculated kappa coefficient using a ground truth dataset. And we automated these processes and executed of around 100 test cities. Next, I'd like to show the results. This shows the results of accuracy assessment. The column shows the kappa coefficient. More than half of the test cities were considered as slight or fair agreement. It means that the vegetation land cover, such as agriculture field or forest in selected area, was misclassified as urban. I'd like to explain the misclassification using the example. This is the original sun image, and using the coarse resolution urban extent map, we selected areas around the urban. And we detected urban areas. Comparing the classified images and Aster post-color composite images, we can see the misclassification, such as in the red circled area. The region is vegetation land cover, and it was misclassified as urban. In this study, we executed pixel-based classification, so it may cause misclassification due to the to do similarity in surface reflectance among defined land cover. To reduce the misclassification and to deal with the problems, it may be useful to use vegetation mass by optical sensor, especially for vegetation land cover. And it may also useful to introduce texture analysis method such as GLCM or graded co-occurrence matrix method. This slide illustrates about GLCM. Using the moving window, the red moving window, we calculated adjacency relationship of pixels and generated co-occurrence matrix. And using the matrix, we calculated texture features such as coloration, variance, entropy, and so on. The lower right images are the example of texture features using pulsar HH images. As you can see, it has a possibility to distinguish urban from non-urban using the texture features. So it has a potential to the bright point and bright area has the potential to be 3 points of our areas in combining the results of ISO data clustering. I'd like to conclude as follows. In this study, we consider an automated method for global urban area mapping with pulsar data. First, we choose around 100 cities as test sites over the world. And second, we masked non-urban areas using existing coarse resolution global urban extent maps, and classify images and deleting urban areas automatically. For future works, we would like to examine and select more accurate and robust classification methods, and parameters such as texture features. And to improve of the accuracy, we'd like to integrate with Asta-Grenier classification algorithm. That's all. Thank you for your attention.
Thank you. Is there any questions? Please.
Thank you. What do you search in Asia country? Taiwan, Hanoi, and Singapore? And how do you search it on 100 city? How do you search it 100 city? That is your conclusion. Yes. Around 100 cities. How do you search it 100 cities?
In this case, in this study, we focus on the cities where the population is over 100,000, and we choose the cities from the cities where the population is over 100,000. That is an example of the cities population is over 100,000.
So your criteria is population?
Yes.
Thank you.
the justification for your research is very clear. But I think that this is a difficult problem because urban is not a physical concept. I mean, classifying something as urban is a conceptual notion, and what is urban in Southeast Asia as opposed to what is urban in, for example, in the United States, the commonality is that there's clusters of people, but the quality of the structures, the density of the structures, the degree to which the structures are interrupted by vegetation, by roads, it's going to vary a great deal from one city to the next. So it seems to me that you're going to have difficulty even if you start to integrate more sort of regional features like texture features where you're not looking at individual pixels. Unfortunately, I don't have a solution to suggest, but the reason that your results were not all that good, I think, is partially because this is conceptually a very, very difficult problem to apply worldwide, even though I think it's extremely valuable, as you pointed out.
Response?
Yes, it's a difficult problem. So,
Okay, you can go back and by the way, my suggestion is if you want to classify those urban area, maybe you can use more advanced classifier. I think ISO data is kind of old and conventional method, so you may consider reclassifier if you will helpful. Any comments? Okay, Professor.
I just would like to add on a small idea of mine is you used pulsar
yes,
because of the radar
yes,
characteristic, and the ASTER data is more or less optical.
yes, optical.
Yeah. But in the end, you return back to the ASTER as your future intention to incorporate. So you deviate from the optical and you go back to the optical. Is that a contradiction? Don't you think so? You should stay with pulsar and use other radar data to intensify your capacity. Radar is always cloud-free or cloud-penetrating. Perhaps you should think of this nighttime light data. That's very individual and interesting. Of course, that's a subset of your urban coverage area. The microphone is yours.
You mean why do I use Foxtrot?
You go from active satellite image, then after you finish your research, you want to add passive satellite image to enhance your result. So that's kind of I mean, you should stick to your pulsar satellite image.
Pulsar is one of the alternative data for ASTER. One just alternative data for ASTER image.
And Professor will provide another valuable point but you can use a nighttime strip light because you can identify light density to represent population. I think it's a good point. You may try in your future work.
If I may add one comment, I think the purpose is clear. You want to map large urban centers in the world. So then I think the approach that you're using, which overcomes the previous comment, is to use an image fusion approach, a data fusion approach. You use the best source to map the city, which normally is optical because you can see the detail, but you have the problem of cloud cover in many tropical regions, so you replace the clouds in your optical with the SAR image, yeah? And you fuse it so that you can complete the analysis, and you use the nighttime light data to complement again. But each one has its advantage, each one has its limitations. The SAR data has the disadvantage in the tropical areas where there is cloud, that in the tropics, also in the cities, there is very tall vegetation everywhere, which will cause misclassification. The light, the nighttime image, also causes big errors, because I've been in the nighttime in Pyongyang in North Korea, which is a city of about 3 million people, but there are no lights, they don't have electricity. So it's just dark, the whole country almost is dark on the nighttime image, for example. So that's also not by itself a reliable source. The SAR by itself is not a reliable source. The optical by itself is not a reliable. By fusing these data, you can get, I think, a more accurate result by combining the two. So I think you need the combination, optical plus SAR, plus maybe nighttime data, plus maybe some high resolution data to get the structure of cities. Yeah, like you go to Beijing, very wide streets, because it's only grown the last 20 years. Or you go to Rome, which is 2,000 years old, very narrow streets, not very straight. So the structure of old cities, new cities. African cities have no concrete. They're mostly made mud or clay with grass roofs. The cities is quite different. On the radar, you don't get very good signal return from the grass roof or the mud. So I think you need to use the different sources together to get the best result. Thank you.
Good idea. Multiple sensor imaging fusion is I think is one of the solution. Okay. Any other comments? Thank you. Thank all of you joined us in this session, and the sixth presenter gave us a wonderful presentation. Thank you very much. Wish you have a pleasant time in Taipei.